Hello, I'm honored to be part of a speaker series at the DEIA Champion Speaker Series at the National Heart, Lung, and Blood Institute, which is a branch of the National Institutes of Health, NIH. And the name of my presentation will be The Anatomy of Conscious and Unconscious Bias. I don't believe this speaker series is available to the general public, so I thought I'd make my own version of, at least of my speech. Right, so here we have the human brain. And coating the entirety of the human brain is a ½ centimeter of gray matter called the cerebral cortex. The cerebral cortex is made of cell bodies, and it's where we make our decisions, where we have our highest level of cognition. And it surrounds the entire brain, left to right, front to back, even dips underneath of here. It dips into all of the sulci and all of the fissures as well. At the back of the brain, you have the sensory cortex, which processes sensations, but it also stores information about the outside world. You can bring to mind the concept of a cotton ball and how it feels and how it looks, because that information is stored in the sensory cortex. So this is our fact center, our data center. At the very front of the brain is the prefrontal cortex, responsible for our highest levels of human cognition, personality, judgment, reason, and decision-making, most importantly, for what we're talking about today. And then we have the motor cortex, which is responsible for movement, for voluntary movement. And it's the behavior center, because behaviors are just series of movements that are enacted by the muscles of your body in a specific series and a specific sequence. So for example, right now I'm gesticulating with my fingers and I'm moving my teeth, tongue, and lips to create words. I'm lecturing, and that is a behavior which is enacted by the motor cortex. Okay, so the sensory cortex for information, data, the prefrontal cortex for decision-making, and the motor cortex is our behavior center. Now, it's a little simplistic to say these things because there are other parts of the brain that are always involved in all these levels of cognition. For example, the motor cortex is always going to have some modulation in actually several other areas of the brain before it commands a movement. But nonetheless, these are the three parts that are most responsible for basically the highest level of command of all of these types of thought. I'm also going to add to the picture the limbic system. Now, the limbic system is not part of the cortex. It's deep inside. It is our emotional center. It has a number of structures, but we're really going to be focusing today on the amygdala, which has a number of purposes, but for our purposes today, it's going to be our fear center. We're not going to be talking so much about reward today, but it is important to say that in the limbic system, we all also have kind of an opposite emotion, which is reward, with these two areas here. And these are the two areas that help to motivate our decisions. So let's talk about how we make decisions under calm circumstances. The ideal decision takes information from the sensory cortex, like I see a yellow shirt. The limbic system also gives some information saying, for example, I like wearing the yellow shirt. And you notice that they both send their information directly to the prefrontal cortex, among other areas, of course. It's always more complicated than a single arrow, but that's the idea. And then the prefrontal cortex says, well, let's go ahead and put on the yellow shirt, and sends the information to the motor cortex, who goes ahead and sends the information through the processing and then down the spinal cord eventually and out to your hands and arms to put on the yellow shirt. So that's the most ideal situation, but there are some instances where the limbic system just takes over. It is important to have the limbic system involved in decisions generally because emotions do help to give us a motivation to actually carry out decisions, but a problem comes in when a person is under duress, for example, and under stressful conditions. The limbic system may actually be more in charge of your behavior than it should be, and it may actually completely bypass the prefrontal cortex in certain very serious conditions to completely enact a behavior basically where the limbic system is in charge. It's not a good situation. So I want to just add one little area here. I've drawn a black circle around what I call the bias center. So it turns out that when you place a participant into a functional MRI and fMRI machine so that you can read their brain activity in real time, and then you elicit an experience of bias, there are different parts of the brain that will light up depending on the type of bias. But there is always going to be some activity in this area in here, in this intersection between the emotional center, the decision center, and the behavioral center. There's always something going on in this area. And so it's basically where it's in the interaction between these three that we have the actual experience of bias. Now, other areas may light up, like if you're listening to a politician and you don't really like what they're saying, your auditory area will light up. Or if you're shown a face from an out group, this is your fusiform gyrus, that will light up because that's where your faces are mostly processed. But, and so an out group is basically you have a self-identified demographic, and anybody that's not part of your self-identified demographic would be considered an out group, and it is very common to understand biased situations based on your out group. So a face shown from your out group may give you a condition of bias, and you'll have lighting up in this region in here. Okay, so what I want to do now is I kind of have to give a little bit of a trigger warning here, but I am going to be showing you a situation that's actually a fairly standard research process where you show the face of somebody holding an object. And basically it's an emergency situation. Your brain has to determine whether you are going to shoot them. So this is the individual, as you can see. If he was part of your out group, an African-American individual was part of your out group, then you might misinterpret his neutral expression as aggression or anger. There's plenty of evidence to suggest that faces in your out group wearing neutral expressions will be misinterpreted in that way. In your in group, they would be correctly interpreted as being neutral. You'll also notice, of course, that he's holding a dark metal object. So in order to answer the question, would you shoot this man? I'm going to show you 4 studies and you can make the conclusion for yourself. First of all, we have to determine that there actually is a physical connection between the amygdala, which is your fear center, and the motor cortex, which is your behavioral center, and indeed there is. Here's your amygdala, your fear center, here's the motor cortex, which enacts behaviors, and you can see that there's actually quite a strong synaptic connection directly between them. Secondly, you have to understand that the amygdala, the fear center, changes under conditions of stress. Normally this is its activity under normal conditions, and then when you elicit in a condition of stress, it transitions the brain to a state of heightened arousal, and this leads to a conditioned expression of fear, which then makes it more likely that a person is actually going to be acting on their fears. So here we have, as you can see, quite a different activity when this is elicited. I want to spend a moment on this study because I really want to talk about what happens in this study, because it's sort of the crux of what I'm discussing today. Emotions occur at an unconscious level. So in this case, they had 13 white participants, and the 13 participants were, it's important to say that all participants reported internalized desires to respond without prejudice. In other words, they consciously identified prefrontal cortex as non-judgmental, non-prejudiced. They did not identify as racist individuals. All right, but nonetheless, they had some unconscious fears when it came to outgroup faces. So they were given either at a 30 millisecond time course or a 525 millisecond time course, a very quick flash of a face, either an in-group face, a white face, or an out-group face, which in this case was a black face. And at 30 milliseconds, their amygdala lit up, and it's important to note that this is literally unconscious activity in the brain, because 30 milliseconds for most people is not enough time to gauge that you were even shown a face at all, much less whether it was a white face or a black face. So there's no higher level processing happening here at all. It's entirely unconscious. However, at 525 milliseconds, the prefrontal cortex was now engaged. They were able to consciously understand that they were being shown a face. They were able to see whether it was a white face or a black face. And with white faces, of course, less activity in the amygdala. With black faces, there was still activity in the amygdala, but the prefrontal cortex basically took over and said, no, there's no threat here, calm down. So again, I just want to reiterate, 30 millisecond time course, all amygdala, and this is unconscious level of activity. 525 millisecond, prefrontal cortex is involved. This is your conscious values speaking up now. And then the last one, of course, is just some statistics that we all kind of already know the story, that when encountered with a decision to shoot context, you're given this scenario, and unfortunately Black people are treated differently from like everyone else. I really like this study because, first of all, it showed Black, Latino, Asian, and white faces, and these were individuals either holding a gun or holding a different object. And well, in this study, it was basically a video game. You're sitting in front of a keyboard and you were able to just press a button. So you weren't actually shooting a gun, but you were pressing a button that said shoot or don't shoot. And you had to quickly decide whether the person was holding a gun or not, or whether they were holding a different object. And then you would see if you could make the correct choice. College students were tested on this, and police officers under non-stressful conditions, basically at a seminar that they were attending. So I thought this was a powerful figure because it shows a couple of things. First of all, when Black people are holding guns, it takes very little time at all to determine that they're holding a gun, as opposed to Latino, Asian, or white people. And secondarily, when they're not holding a gun, it takes much longer to determine that that Black person is not holding a gun, as opposed to Latino, Asian, or white people. So this kind of puts statistics on something that we kind of already know, is that Black people are oftentimes considered threats, and that our brain will react as such. Well, what can we do about it? What I want to say is that the police officers actually had a better success rate with this experiment, but overall, and a number of different experiments have been done with this, I believe the success rate is about 94%, pretty high. Police officers actually do better than college students on these kind of studies. But a 94% success rate means that there is a 6% error rate. Let's put it that way and just leave it at that. So let's take a look at the brain of a police officer. Well, a couple of things that we have to show, of course, is that everybody has an amygdala. I would assume that pretty much everybody is going to have an amygdala. You can't really help it. You can help the amygdala actually learn differently, but the amygdala is going to be sort of what it is, especially if you've never had any kind of therapy or pharmaceutical intervention, for example. Your amygdala is going to be showing fear, especially with an out group, and possibly especially for Black people, if they are in your out group. Or perhaps even when they're in your in group in certain circumstances. But I also want to say that police officers will have a motor cortex with a neural network that is set up specifically for a behavior which has been strongly replicated in their brain, that they are to shoot a gun. Myself, if I were to hold a gun, it would take me a little while to actually shoot it. But police officers go to gun ranges, and at least one video I've seen is that they literally use the mugshots of Black people as a target, which I hope they don't do that anymore. But what that's basically saying is that I am setting myself up to shoot a gun, not only just to shoot a gun, but to shoot a Black person. That's a strong neural network that is already in place. So what can be done? Neuroplasticity, synaptic plasticity. The basic idea of learning means that you are changing your brain. You learn a new skill, you learn a new fact, and there will be changes made in your brain. I don't really have the time to go into it today, but just suffice to say that there are, I did talk about this in my TED Talk a little bit, and suffice to say that you can change the interactions in your gray matter, and you can actually reorganize your white matter as well. These are the tracks of neurons that basically take information from one area to the other. So you can actually change your brain physically when you learn new ideas. In the case of a police officer, when I was living in Chicago in my 20s, one of the things they were always talking about was that the police officers were too violent, and they were thought to be quite racist, especially in certain neighborhoods. And the idea was, and it was floated many times, to get the police officers out of the car, walk on the streets, right? Now we're establishing a new neural network. Rather than just driving through, we're walking through the streets, we're shaking hands, we're having conversations, we're playing kickball with the kids, and we're getting to know people, and we're establishing new, basically anti-racist neural networks. It's long work, but it's worth doing, especially when, life and death is at stake, I feel like. I don't believe those programs have ever gone into place that I've ever heard about, but it was floated all the time. So yes, we have to make new neural networks. So how do you do that? Well, in most of our workplaces, such as here in a scientific community, we're not usually dealing with life and death choices. We're not dealing with emergencies, but we're still dealing with a much lesser version of all of this stuff. We're still dealing with biases all the time. So first of all, hiring practices. You want to get more diversity into your hiring practices and into your leadership. When you have more diversity, you have less systemic bias because that helps with your cultural plasticity. I talk about that in my TED Talk as well. I don't have time for it today, but you can kind of gauge what that basically would be. Cultural plasticity, the whole region changes when you get more diversity in. Second, you have to face your biases. This is the hardest step because oftentimes people don't want to think of themselves as biased. And at the first encounter, maybe in their entire lives, in their 50s, for example, when they suddenly come across evidence that they were biased, they oftentimes want to argue, they get defensive, they want to ask for evidence, and they basically want to deny that it's true at all. But if you are lucky enough to have people actually telling you that you're being biased, you have to put away your defensiveness and your ego, and you have to just listen to them and understand they are telling you the truth. So that's really the best way to face your biases, is to have someone in your life tell you you've been biased. I've been lucky enough, I will tell you, in my adult life for four different situations where people told me I was biased. The first time when I was 20, the fourth time just recently this last January. I will say that it's gotten easier and easier as time has gone by. It used to take me years to admit to my bias, and now it's like I admit it right away. This last January, I basically had a student saying, check your privilege, and I immediately said, oh yeah, you're right. Well, even if you don't know you're biased, you are biased, you exhibit biased behaviors 100%. But even if you cannot identify them and you feel a little helpless, understand that if you are a person with privilege in your workplace, that you are at least benefiting from a biased system, from a system where you have power and other people do not. And it's very difficult to see that from the inside. That's why it's so helpful to have truth tellers tell you so. But just understand that it's true. It's just true. If you are a white, male, cis, het, Christian, able-bodied individual, you have you just have all of the privilege, and you're benefiting from your privilege, whether you see it or not. Just understand that it's there. Lastly, the third step, even if you cannot get through step 2, just jump to step 3 then. Just start practicing non-biased behaviors. Start doing things that are non-biased, non-sexist, support women specifically. But don't just think, oh yes, well I support women. Do things that actually support women. Might I suggest that if you're part of a committee, that you take on some of that pesky administrative work that women oftentimes take on, like taking the minutes or making phone calls or making connections and things like that. Just volunteer to take on some of those duties, because we all understand that women take these on all the time, but men rarely volunteer for these situations. So you could be the one who volunteers for them. That would actually help out a lot. Even if you're like a really senior employee, you specifically doing something like that would really help out, change the tone of your committee, in my opinion. And of course, if you're somebody who kind of sits back, crosses your arms, and just expounds on your opinions and loves the sound of your own voice, you know who you are. Stop talking. Stop talking so much. Turn to a woman or a person who's neurodivergent or a person who is transgender and you don't really understand the whole thing and you haven't engaged yet, but go ahead and turn to them anyway and just say, what do you think? What's the harm? And maybe actually listen to what they have to say. Something to consider. Anyway, whatever you do, make sure that you are practicing non-biased behaviors, that you put these neural networks in place. And I would just like to say it's such a privilege to be here, to be invited to this series, and I really appreciate the opportunity. I said a lot of things today. If you want to, you can check out my website, maggiewenzel.com with 2 L's, or just send me an email. And good luck. Thank you.